All right, so the next thing we're going to talk about is implicit differentiation of a function with two or more variables. Now, way back in Calc 1, you would have learned how to do implicit differentiation in actually a more roundabout way when you just had x and y. So I've got a couple here which just have x and y, and I'll show you how they're the same. Just using this formula will make it a lot easier for you. So first of all, the formula, if I'm taking dy dx, which is similar notation, so the function of y with respect to x, and again, our function is just going to be a two-variable function. We take the derivative of x and put that on the top, and we divide it by the derivative of y, and we have this negative here as well. And similarly, if you've got multiple variables, then you can solve these as well, depending upon what's being asked of you. So let's take a look at the first one, number 230, and let's solve it using this formula. So we're looking for dy dx, and that equals essentially fx, which is the derivative of f with respect to x, over fy, and that's all negative. All right, so the derivative of this with respect to x, well, the derivative of sine of 6x is 6 cosine of 6x. The derivative of the tangent 8y plus 5, it's all a big constant, so that's 0, so we leave that alone. Sorry, we need the negative out here. And then our denominator, we evaluate the derivative with respect to y. Well, the sine of 6x is a constant, that goes away. Derivative of that's 0. Derivative of 5 is 0, so we're just looking at the tangent. And derivative of tangent, secant squared, so we're looking at 8 secant squared of 8y. And you can reduce the 6/8 to 3/4 if you want. And you've got a cosine of something that's different over a secant, so that's not really going to help you out much. So I'm going to leave that alone. Let's do 231. So dy, and let's do a different color here. dy dx is equal to negative fx, so derivative of f with respect to x, and derivative of f with respect to y. All right, with respect to x, we get 3x squared plus y squared, because the y squared is a constant, and we just have x. Derivative of x is 1. Derivative of negative 3 is 0, so we're good on the numerator. We've got it all negative here. And then our denominator is going to be, with respect to y, well, we lose that x cubed. We lose the negative 3, so that's just going to be 2xy. So that's what we have there. And you would get the same thing if you solve this implicitly. You can test that out for yourself. Just, change the, 2y, y prime, and so forth.